All right, for today's challenge problem, you are given the ultimate physics brain buster. At least this is what people say, and you might realize it's not nearly as bad as they say. So let's see the problem. Two trains on the same track are heading towards each other. One train leaves LA at 9 a.m., heading east at 70 miles per hour. The other train leaves Las Vegas, which is 260 miles away, at 11 a.m., and is traveling at 60 miles per hour. Determine what time the two trains will collide. Don't worry, no one was injured in the making of this story. They found out in time. Well, that's if you can solve the problem. All right, so what I want you to do is see if you can figure out exactly what time the two trains will collide. And I want time of day, all right, because we use actual times of day here. All right, so what time of day will the two trains collide? And pause the video now. We'll be back with the answer in 3, 2, 1. Okay, all right. So you should have paused the video, but like I said, we're going to reveal the answers. So here we go. Here's the revealing of the answers. First step I did was I drew a graph. I guess the series of graphs. So here's my graphs. Boop. All right, so here's my graphs. So I did position time graph. That was my choice today. And we had, I gave them A's and B's. So I determined that A was the one leaving Los Angeles. And so we have it starting 200 meters away, or 200 miles away, 60 miles away. There's my brain. And I denoted the slope. So it's got a slope of -70. I guess it should have been the positive one. Looking back on it, considering it says east, but potato, potato. It just cared about time, not position. So I guess I should flip this. Oh, well, life goes on. I'm not redoing my math. And so I just drew that. You normally you'd pick, but I guess I should have gone with the flipped because it's east. And then I went with the other one, leaving Las Vegas at 11 a.m. And I made that positive. So it's going up and to the right. I denoted 11 a.m. and 9 a.m. here. And if you want, for mathematical purposes, I'm basically changing that to a 0 and a 2. And I'll bring that back in at the end. All right, so you have to have this first. And like I said, I guess you really should have flipped these two, but not the end of the world. All right, so then let's see what we got here. Next would be actually writing the equations out. Now I'm based again off my graph. So let's show those equations. Boop. All right, there's my equations. So my equations are based off of the linear equation for constant velocity. So A would be position equals -70t plus 260, because again, on my graph, it has a negative slope. And then x equals -60. Sorry, x equals 60 times the quantity t minus 2. Now, how to get to t minus 2? All right, so remember, that one left 2 hours afterwards. So that's why we're subtracting 2 from it, because it left 2 hours after the previous one. All right, if you want to kind of double check your work, it's real simple. You basically just put like a t of 0 in there. And if you realize, if you go back to time 0, then B should be in the negative region because it would be below right here. You'd kind of back up. So it'd have to be in a negative position than 0. And so it'd be even farther away. And so that's why you get the negative. Because if you had this as like a +2, then this would be a positive position, and that does not make sense. All right, so these are my two equations. So then all I do is I set them equal to each other and do a whole bunch of algebra, and I get this. T equals 2.92 hours. Now again, I adjusted that, so we're leaving at 9 a.m. And so we are going to hit at 11:55 and change. It's like 11:55 and then point blah, blah, blah. So we're going to basically have a collision at 11:55 a.m. So I hope they were notified in time. All right. So if you can do this, then you are good to go. Hopefully you do better than me and you made these flipping negatives and stuff like that, and you'll be fine. You'll still get the exact same time, but like I said, if I was this again, I would have made what? Because this is supposed to, this one going here, this is supposed to be negative. So I'd have that going down. I'd probably have it leaving a different time. So little adjustments there. So yes, maybe I'd make time 0. I'd figure something out. Useful mark. All right. Well, anyways, that's how you solve it. On your mark, get set, do more physics.